This is Algebra 1, Lesson 7.1. We're introducing systems of equations where we're solving linear systems by graphing using the graph and check method. On page 398 is where we begin. Two definitions to begin. First one is, what is a system of linear equations? It's two or more, because it can be more than two, of a two or more linear equations in the same variables form a system of linear equations, or simply a linear system. So when you're looking again on one plane in the same variables, that's what that means. Variable x, your x-axis, and variable y, your y-axis. When you have two equations, one going like that and one going like that, that creates a system where only one point solves or makes both of them true. A solution is that one point that I just showed from a second ago. The solution is the one point where this line intersects with this line. The only solution, the only one that'll make both the way I have them drawn up here, the red and blue line correct, is that purple intersection right there. That is the only point that when we plug in its x and y value, or its ordered pair, will make the blue equation true and the right equation true, therefore being a solution for each one and a solution for the system. So we have 4 steps to start with of how to solve using the graph and check method. The first step is to write each equation in a form that is easy to graph. Notice it does not say anything about which form to put it in. It says one that's easy to graph. If it is easier for you to plug in x values in an input-output machine, to just get it into function form and plug in -2, -1, 0, 1, and 2, yes, that is a longer way to do it, but it may be easier for you to do it that way. For most of us, the easiest form to graph in is slope-intercept form. Y is equal to mx plus b. Some of us are comfortable graphing with the x and y intercepts by plugging in 0 for both of them when it's in standard form. And some of us are even capable of graphing in point slope form. But again, notice it does not specify which form to write it in. Write it in a form that is easy to graph. Step number 2 is to graph both of them in the same coordinate plane. So if this were a coordinate plane and you graph both equations, one of them would look like this, for example, and it could be anywhere as you want. The other one would look like, let's say, find a good intersection, this. Okay, that would be the other one there. Just graph both of them in the same plane. Again, in a form that is easy for you to graph. Step number 3, and I'm going to copy this on over real quick. Step number 3 is to estimate their point of intersection. So this is the hardest part. Not because it's hard to estimate what the point is, but if any of your lines are not graphed straight, so you need to have a straight edge when you're doing this, oftentimes it's hard to determine where the point of intersection is. Estimate what that point right there is. The way I have them drawn right there, I would estimate its x value being 6 and its y value being -2. So that's what it means by estimate the point of intersection, x comma y. The third, step 4, is to check those points by subbing in that x comma y value. So again, on that one, I had 6, -2. So just like on our bell work, we plugged in x and y to see if we got a true statement. Plug in your x and y value and see if both equations are true. This is why it's called the graph and check method, because you graph them, you estimate what the intersection is, and then you check it. So here's example number 1, using the graph and check method, not hypothetically, but what if we have 2 equations to go with it? 5x plus 4y is equal to -12, and 3x minus 4y is equal to negative 20. Remember, step one told you to get it into a form that is easy to graph. Again, for most of us, something that is easy to graph is slope-intercept form. So make it say y equals mx plus b by moving over, in this case, 5x. Remember, if it's positive 5x on the left, once it moves over, it becomes negative 5x. You still have negative 12 on that side, and you still have 4y on the left. Then, in order to get y by itself, divide everything by 4. When you divide everything by 4, you have negative 5 over 4x, and you have negative 12 divided by 4, which is negative 3. Now this says y equals mx plus b. So your m value, or your slope, is negative 5 over 4, and your b value, or your y-intercept, is negative 3. That's the first equation, getting your m and your b by making it a slope-intercept form. The second equation, we want to move it again into something that is easy to graph. So again, for most of us, that's something that is easy to graph is slope-intercept form. So we move over 3x from one side to the other side. It's positive. You undo it by subtracting 3x, or if it's positive when it goes to the other side, it becomes negative 3x. So negative 4y is still on the left. You now have negative 3x on the right, and negative 20 is already on the right. Then get y by itself by dividing everything by negative 4. Negative 3 divided by negative 4 is positive 3 over 4. Remember, negative divided by negative is a positive. And negative 20 divided by negative 4 is a positive 5. Again, a negative divided by negative is a positive. Therefore, your slope in this case is 3/4, and your y-intercept, or your b value, is 5. So we have two equations that we can graph. I have them listed as a red and a blue equation. You're probably writing in one color, which is fine. Just make sure you distinguish between the two equations. The next step, after you get them into a form that is easy to graph, the next step is to graph both of them on the same plane. Now, I gave you a blank window right next to it, and it's kind of small, but it'll suffice. So shift your window to where your y-axis is all the way over here on the left. So draw yourself a y-axis all the way over here on the left. Your x-axis can be in the middle. That's fine. It's not going to make a difference. Then when we graph the first equation, if we graph y equals mx plus b, this one right here, your b value tells you to begin at negative 3. That's that point right down there, 3 below 0. Your m value is negative 5 over 4. So that tells you to go down 5 and to the right 4. Now, the way we got it on our graph, remember, your negative doesn't matter if it's at the top or the bottom. Since we can't go down and to the right because we're going to run off our graph, we can make it say positive 5 over negative 4, which tells us to go up 5 times. 1, 2, 3, 4, 5, and to the left 4 times. 1, 2, 3, 4 times. So that's the second point, and then you could draw a straight line. And again, I emphasize the word straight because it'll be hard to determine where the intersection is without a straight line. So from there, we can draw ourselves a nice, neat straight line through those points, and it'll look just like that. We could do the same thing with the other equation, the one that I had listed as the blue one, beginning at 5 this time. 1, 2, 3, 4, 5 right there. Its slope is 3 over 4. Again, both of those are positive. Positive 3 tells you to go up 3. Positive 4 tells you to go to the right 4. But what does negative divided by a negative give you? Also a positive. So going down 3, let me put it in front, down 3 and to the left 4 gives you the same effect. So down, and I'm only doing this to make it fit on the graph on the window itself. Down 1, 2, 3, and to the left 1, 2, 3, 4. Again, that's the same spot as it was a second ago. Once you have those two points, You can draw yourself a straight line through them. Again, we'll do it with blue to distinguish the two. Not that one. We'll do it with blue to distinguish the two. And we could see both of our equations going through. Now, the next step after you have both of them graphed, so step one was to get them into a form that was easy to graph. Step two is to graph both of them on the same plane. The next step is to estimate what that point is. What is this point right here? And again, having straight lines will help with this tremendously. If you have straight lines, we could estimate that that x value is -4 and its y value is 2. And again, all you're doing is going from 0, 0, -1, 2, 3, 4, and up 1, 2 for your x comma y, -4, 2. So this is called graph and check. Again, we graphed it. We estimated what the point is, -4. The last part is to do the and check part. For equation number 1, in place of x, we're going to plug in -4. And in place of y, we're going to plug in 2. So 5 times -4 plus 4 times 2. 5 times -4 is -20. Plus 4 times 2 is 8. -20 plus 8 is -12. We can see very clearly that for equation number 1, which I listed as the red one, is a true statement. Therefore, that point, -4, 2, is a solution to the red one, or to equation number 1. The second equation, again, we'll plug in -4 for x and 2 for y. So 3 times -4 is -12, and -4 times 2 is -8. And again, when you're doing this, you'll notice quickly that you're working with a lot of the same numbers. That's not a coincidence. -12 minus 8 is -20. Again, we have ourselves a true statement. So we have two true statements for both equation 1, or the red one as I had it listed, and equation 2, or the blue one. Therefore, because -4 and 2 is a solution of each one, it is a solution to of the linear system using the graph and check method. On the back, let's do this one. It's already graphed for you. So the line with the positive slope is y is equal to 3x minus 12. The line with the negative slope, because you can see what the m values are very quickly, is y is equal to -2x plus 3. It says use the graph to solve the system and check the solution algebraically. So as we look at these two equations, that is the intersection. So take 45 seconds and plug in that point and see if you get a true statement for both of those equations. So I would name that point 3, -3. That's its x and y value. So the first equation, y equals 3x minus 12, instead of y, -3, equals 3 times x, instead of x, 3 minus 12. -3 equals 3 times 3 is 9 minus 12. So -3 equals 9 minus 12. Those are opposite signs, so you subtract them. 12 minus 9 is 3, and you keep the sign of the larger value. Therefore, 3 negative 3 does work for the first equation. You can put a little check by that one. Do the same thing with the second equation. Y equals negative 2x plus 3. Instead of y again, we're going to plug in negative 3 equals negative 2 times, instead of x, again, we're going to plug in 3 plus 3. One thing I see students doing is they'll use parts of one equation and parts of the other. So if you need to, cover up the first equation where you don't do that. Negative 3 equals negative 2 times 3 is negative 6 plus 3. Negative 3 equals, again, 6 and 3 are opposite signs, so subtract them, keep the bigger absolute sign. Negative 3 is equal to negative 3. Therefore, it is a solution to that one. If it is a solution to both equations, then it is a solution to the system. So the answer to the solution of this system is 3, negative 3. It's this point that we originally called it, 3, negative 3. We graphed it. It's graphed already. We algebraically checked 3 and negative 3. On that sheet I gave you that has all those little graphs, on the first one, graph both of these. Follow your steps, 1, 2, 3, and 4. Take about a minute and a half. Graph both of them. Estimate the intersection point, and then check it algebraically. Take about 2 minutes on it. So step number 1 tells us to write each equation in a form that's easy to graph. Standard form for most people, unless it's nice and neat, is not an easy form to graph in, to where you can use the intercepts. Standard form usually falls a little short. 3x plus y equals 11. The easiest form to get this one in to graph it is slope-intercept form. Y equals mx plus b. So you need to bring 3x over to the other side. It's positive 3x on the left, so when it goes over, it becomes negative 3x, and positive 11 is still there. So now this one says y equals mx plus b, where your m value is negative 3 and your b value is 11. So we can graph that equation based on those two numbers. The other one, though, before we graph it, the hardest part for most students with these kind of equations is when you're given a blank window like this, is where to set your x and your y axis. We know that we got to go at least as high as 11, but let's check and see what our blue equation, as I have it written, is going to do, just to see where we have to go. Again, you want to make it say y equals mx plus b. This one's actually set up to where you can use standard form in the intercepts, but just to keep it consistent, move x over. That leaves you with negative 2y is equal to, it's now negative x, and positive 6 is still on the right. Then divide everything by negative 2. This, and this. So this will cancel and leave you with just y. Negative 1 divided by negative 2 is positive 1 over 2x. And positive 6 divided by negative 2 is negative 3. Again, this is slope-intercept form, where your slope value is 1 over 2, and your y-intercept is negative 3. So we know on our graph, our y-intercepts have to go as high as 11 and as low as negative 3. So hopefully on our graphs, which I think the ones I gave y'all may only have 10 on them, you may have to include a couple of extra things. Sometimes that'll happen when your window isn't quite big enough. So when we graph our red one, we know we got to be as high as a positive 11. But for the first one, our x-axis isn't going to be a whole lot different because we don't have to go any farther than 2 in any direction. Our y-intercept, however, has to go as high as 11. So 1, 2, 3. So if 11 is all the way up here on our y, then we'll just go down to where it's 11 down. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. This will be our 0 right here. And again, this is the hardest part for most people, is setting the axes themselves. Not like I just did, but with a nice straight line. And again, drawing a straight line will help you with all of this stuff. So our slope is negative 3. So negative 3 over 1 tells us to go down 3, 1, 2, 3, and to the right 1. So we can draw our line through those 2 points. But before we draw our line, let's put our other equation in. Our b value for our other equation is at negative 1, 2, 3 right here. Our slope is 1 over 2. Tells us to go up 1 and to the right 2. So once we have 2 points, we can see on our graph that our intersection is going to happen somewheres in this area right here. So we know we should be able to see what our intersection is going to do. So from those 2 points, we want to do that, and we want to do this, to where we can see what our intersection is. Now, estimating this is the hardest part. Again, because my line here, the red one, probably should have been turned slightly this way to make it work, and the blue one should have been turned slightly that way. But from that point, so we can estimate that point, its x and its y value being 4 as its x and negative 1 as its y. So that's the next thing you have to do is estimate that. Then take those two numbers, x and y, just like we did on the bell work, plug them in to both of the original equations and see if it's a solution to the equation. So this first one, 3x plus y equals 11. 3 times x plus y equals 11. We could see when we plug in 4 in place of x and negative 1 in place of y. 3 times 4 is 12, plus a negative 1 means minus 1. This gives us a true statement. 11 is equal to 11. Therefore, it is a solution to that one. When we do the same thing with the other equation, instead of x minus 2y, we'll have negative 1 in place of x, minus 2 times, remember it's x comma y. Instead of x, we'll have 4 minus 2 times y is negative 1 is equal to 6. Remember, a negative times a negative is a positive 2. So 4 plus 2 is 6. That is also a true statement. 6 equals 6. Therefore, that is a solution to that one. So your solution to your systems of equations is 4, negative 1. And that's the solution right there.